Hello, my name is Jay, and today I will be going over the results of my Physics Lab 1 report on observational and computational objects in constant velocity. For my introduction, the purpose of this lab was to utilize computer software to compare both an observed and computational model of objects in constant velocity. And for my models, there was a utilization of the Python starter code, as well as the website and the tracker software. The biggest physical or the most important physical principles used in this lab were Newton's first and second laws, also in the form of the momentum principle. And as a quick result, my observational velocity was indeed not constant. The biggest factor was drifting. For the physics ideas, the most important ones were predictive motion. And as I've said, utilizing the momentum principle as Newton's second law, I was able to derive the equation of V final equals V initial added to the net force divided by mass times the change in time. Because this lab was in an assumption of constant velocity, though, acceleration would be zero, and therefore net force would also be zero. So the final velocity would just equal the initial velocity. This makes the motion equation or the position equation a lot easier, as predicting future position would just be r initial plus the final, or in this case, the initial velocity times the change in time. For the system in my observational model, I used my tablet as a ramp along with a full soda can and the hardwood floor, which in my case had the lowest coefficient of friction or had the lowest friction. With this plugged into Tracker, I was able to output a lot of values, which then I used in the graph. For the computational model, I changed certain values in the starter code, such as the mass of the ball, which was 340 grams, presenting a full soda can, the initial position, which was found in the values in my tracker points, and the initial velocity, which was also calculated from the tracker values. There was also a change in timestamps because I wanted the values outputted in the code to be similar in terms of number to the values given in the tracker software. For the while loop, I set time to be less than 1.933 because that was how long it took the video to run. And although I changed the equations for ball velocity and position, they essentially perform the same tasks as the initial equations given in the starter code. For the graph, as you can see, the observed model was most definitely not in constant velocity, since it reached slower or lower positions compared to the predictive models as time passed. Although there was a very similar trajectory in the start of both models. For the errors, can trajectory or drifting was definitely a big part. This was also what I concluded to be the biggest cause of a difference between the two lines in my graph. If there was no drifting in the can, or if the tracker recognized that the can was not drifting, I believe the speed for the further time periods would be a lot more similar. In addition, there was also tracker point placement because the can was in motion and it was a small object, which made the frames very blurry. There was definitely human error in trying to place the midpoint of each can per frame. Discussion of the what if question. If the axes were flipped, my graph would then look very similar to what was seen in the pre-lecture videos. In the tracker software, I set my axes in the very far left, which meant when the can moved from the left side to the right side of the screen, it would have moved in the positive X direction. If I instead set the axes to the right side to move in the negative X position, then my graph would have a downward slope. Lastly, for what does it mean, summarizing the net forces inside at least the computational model, to reach a net force of zero, the force of gravity and the normal force would have canceled out. As a further thought question though, or a diving deeper into the question, in real life, because there was drifting and because there was indeed not no constant velocity, there was definitely the force of friction playing a part. That is the end of my presentation.